Hello, my name is Shannon Henry, and this is my presentation on operating systems and firewalls for ISA 4220, or System Security 2, in the fall of 2019. There are many different types of operating systems available. Each provides different things to the user, so the availability of choices is very good for consumers. Windows 10 and the Windows Server 2019 are very similar, but Windows Server 2019 focuses more on security and privacy. The Windows Server 2019 is one of the two systems that we will be using and setting up in this class. And then Ubuntu and CentOS are both Linux distributions. Linux is an open source software which makes it cheap, if not free, for the user. We will also be using Ubuntu in this class. Mac OS is the operating system that comes pre-installed on an Apple computer, and it's well known for its easy-to-use interface. Now we're just going to talk a little bit about how operating systems work. There are a few main components or jobs of an operating system that are pretty important, and the first is the kernel. The kernel is the first thing that will boot in an operating system. It will allow for the communication between the hardware and software components of the computer. So you can see in the illustration here that it acts as the mediator between the applications that you see on the computer and the actual hardware components like the CPU, the memory, or the devices that are attached. The next important job of the operating system is the process management. The operating system makes sure that the processing power is spread as needed between all running applications. It ensures that one application does not use all of the processing power while leaving no processing power for another running application. And then the last is memory management. Memory allocation is a large responsibility of the operating system because it must manage three different types of memory: the CPU, cache, the RAM, and the hard drive storage. It will ensure that each running application has the maximum memory it can allow, and that they each have separate memory addresses so that the memory does not get tangled between two applications. Here are some hardening recommendations to make the operating system more secure. Operating systems will regularly alert users to update the software. Users should always be doing this because the operating system patches could be fixing a vulnerability that was found. It's very important for security that these updates get done often and on time. That way, any vulnerabilities that were patched are taken care of. The next one is to only have as many user accounts as is strictly necessary. This will limit the amount of ways that the server or system can be accessed. It's also very important to remove inactive user accounts, particularly if in a company an employee leaves, their account should be removed immediately from the system. Administrative access should only be given to a couple of users that are very trusted. They should only have access if it is completely necessary to carry out their job function, and other users should only have the minimum access that they will need to complete their job. There should be a policy on how strong account passwords need to be, and then that should be tested. There are systems available to test the strength of passwords, and that can also inform users to change them if they are too weak. Users should also frequently change their passwords, such as every 90 days or more frequently, depending on the company. The only applications that should be installed on the computer should be the ones that are vital to the function of the server or the job of the person working on it. Any other applications will just be another potential access point for an attacker. Lastly, it is very important to back up and back up often. If the hard drive fails or if something goes terribly wrong, having a backup can save a lot of time and money. Now we will move on to firewalls. Firewalls are a network security device that monitors incoming and outgoing network traffic and decides whether to allow or block specific traffic based on a defined set of security rules. They act as a barrier between the secure internal network and the insecure external network, or the internet. There are many different types of firewalls that are available. Here I will go over the 5 most common types. Each type of firewall will have rules that it is configured to follow as to whether or not to let a packet in. So that's true for all of these 5 here. These rules can be configured to company preferences. The first is a packet filtering or stateless firewall, which will examine the header of each packet and go through its set of rules to determine if it can allow the packet in past the firewall. The next is a stateful firewall. A stateful firewall will remember significant information about the state of previous connections. It will then compare the current packet to the database of states that it knows, and it will determine if it should accept, reject, or drop the packet from there. The next is an application or proxy-based firewall. A proxy-based firewall inspects the contents of the packet to filter out any known attacks or spam, and then determines based on its rule set what it should allow in. Next is a circuit-level gateway firewall. This type of firewall monitors the network to determine if the packet is trustworthy. It's only monitoring the network. It does not actually inspect the packet for itself, but monitors its surroundings to see if it thinks that it's a trustworthy packet. Then there's a next generation firewall. This type of firewall combines packet inspection, deep packet inspection, and stateful inspection. A deep packet inspection means that the firewall is looking at the contents of the packet as well as the header, and by combining all of these, it can be a more secure firewall. We will be using two types of firewalls in this class. The first is a Windows firewall, which is for Windows obviously, and then an IP tables firewall, which is for Linux. The Windows firewall is a stateful inspection firewall, just as the IP tables firewall is, and it is installed with the operating system, Windows servers or Windows 10, and is on by default. Users can then configure this firewall to their preferences, determining whether or not to allow certain connections. They have more advanced settings, or you can turn it off entirely. It's up to the user completely. IP tables is simply a command line interface that is on top of the NetFilter firewall, which is pre-installed in most Linux distributions. It is a stateful firewall as well. The command line interface, IP tables, allows the user to configure rules for the NetFilter firewall. IP tables will have a set of rules that the user sets, and it will go down the list of rules with each packet to determine if it's allowed through. If it passes one rule, it will then be examined by the next rule, and so on and so forth. Finally, if the last rule says it's okay, then the packet will be allowed through. Now I'm going to move on to the hardening recommendations for Windows Firewall. So this is going to be true for everything in security and will not change with firewalls, but the first and maybe the most important rule is to always be sure to use a strong, unique password to access your firewall configurations. This password should be changed frequently, such as every 90 days, and be very strong so that way it can be as secure as possible. It is also very important to update the firewall frequently to ensure that all of the security patches get installed. Allowing it to update automatically will ensure that updates do not get missed. This can be an important step because it's easy to overlook one update and then an entire security patch does not get installed and your firewall is very vulnerable. It is important as a security administrator to audit the logs of the firewall. This audit will allow you to see which traffic rules are being used the most and which ones are being used the least. This is important information to have so that you know if there are any false positives occurring in your firewall. This means that traffic is not getting through that should be allowed through, which you would be able to see if there were a lot of uses of one particular rule. And then if a rule isn't getting used enough, it could be that there is some kind of workaround that you need to figure out. The next step to hardening your Windows firewall would be to determine which applications can access the external network. It's important to look through the list of applications that are running on the computer and be sure that some background applications that you don't know about aren't just allowing inbound traffic. So ensure only necessary applications are allowed to access the network and then block any unnecessary ones or uninstall them. Now I will move on to some hardening recommendations for IP tables. The table on the right here shows you how packets flow through the IP tables firewall. This is important information to have because you're able to see how your packets are getting accepted, rejected, or dropped, and you can see where in the process that would happen. So in some ways it's similar to the Windows firewall with a few of the recommendations here. You want to be sure to update the IP tables firewall regularly. Again, this is just important to make sure security patches are getting installed. And then you want to also monitor the logs of the traffic and make sure that you are using strong passwords to access the firewalls and changing those frequently again. It's also important to block bogus traffic or traffic from spoofed addresses. So this is something that you can configure in the IP tables. Basically, spoofed addresses are ones that look like they're from inside of the network but are actually coming from the outside network, and those should automatically be dropped. It's a huge red flag because inside network addresses should not be coming from the outside. It is also important to block traffic from ranges of unfriendly IP addresses. There are a lot of known unfriendly IP addresses, so it's easy to go in and make rules to just block these altogether. To make things simpler for traffic that is known to be friendly, it is good to allow traffic from these known addresses that the company or person may communicate with frequently. You can allow them in always, that way the traffic just can come right through if you know it's coming from a friendly source. I wouldn't recommend doing this unless you are absolutely sure that it's a friendly source that you're letting in. These are my works cited pages. Thanks for watching.